Hello everyone, welcome to Dr. Ravi's Academy. In today's video, we will be learning the mass moment of inertia of a circular ring, and the lecture number is 5-2. And let us consider a circular ring with the radius r, and it is something like a tenicoid ring. You can see the tenicoid ring having a uniform cross section area, and having the mean diameter is d and radius is r. So here he is asking the moment of inertia about x-axis, diametral axis, y-axis, and an axis perpendicular to it, that is z-axis is the axis of rotation. So you are supposed to calculate the moment of inertia about x, y, and z-axis. The moment you say that it is about x-axis, you have to assume that it is revolving about x-axis, and it is about y-axis means it is revolving about y-axis, and about z-axis it's revolving about z-axis. So always you will be assuming about the reference axis. It will be revolving about the reference axis. Now you can see that it is something like this. Let us say it is x-axis, it is y-axis origin, and this is z-axis. You can see that it is having a radius of r, right? For this, let us select an element at an angle theta, and this include angle is d theta, and this length is radius is r, and this becomes r d theta. Elemental length is r d theta, and from this right triangle, let us see from this right triangle. So this length will be, which is y. So y is equals to, this is r and it is r sine theta, r sine theta. So like that, this is the component of this hypotenuse on this is r cos theta. This length is, this is x, is equals to r cos theta, right? Now let us calculate the moment of inertia about x-axis. I am using a symbol I. About x-axis is equals to, as you know that formula, it is integral, it is y square dA, it is y square dm, and write the expression for dm. So dm is equals to, it is mass, m is mass per unit length into, length is r d theta, r d theta. So now let us assume that the circumference is 2 pi r. 2 pi r is the circumference, and if you multiply, this is what is length, total length multiplied with this, and you are going to get the total mass. Total mass is equals to mass per unit length, where m is mass per unit length. So you will be using this particular notation. So it is integral y square dm, and y value is r sine theta, integral, it is r sine theta whole square. Dm is, it is m into r d theta. R is constant, and of course you have r square and one more r, that is r cube. M is also constant, you can keep outside, and you have integral sine square theta d theta. The limits of integration is 0 to 2 pi, 0 to 2 pi, and this is a standard integration, as you know that it is, this value is 2 pi, and you are going to get 2 pi, and you can write down this as it is r cube into m, and this value is 2 pi. Sin square theta is, of course, it's not 2 pi, it's pi, standard integration. Substitute this and replace m value, and you have m is equals to, here m is equals to, it is capital M divided by 2 pi r is m value into r cube and into pi, and you have 1 pi will go off and 1 r will, it is r square, and you have m r square by 2. So this is about x-axis, and about y-axis, here it is r cos theta. So you have iy is equals to, it is integral x square dm, and x is r cos theta, r cos theta whole square into dm. Dm you can write down, it is m into r d theta. And this is also having, you can keep that integral cos square theta is again pi, and you are going to get the same value, that is m r square by 2. So after knowing this ix and iy, you can calculate iz. Iz is equals to, using perpendicular axis theorem, that is ix plus iy, and it is mr square. The moment of inertia about the axis of rotation is mr square, and the moment of inertia about y-axis is mr square by 2, and the moment of inertia about x-axis is, that is ix is mr square by 2. So you got all three values, and this is what exactly the moment of inertia of a circular ring about centroidal axis. You have centroidal x-axis, y-axis, and as well as z-axis. For more videos, please watch Ravi's Academy. Thank you for watching this video.